Hello everyone, welcome to my channel. Today we'll be discussing some other problems from the chapter number 1 of the Carruthrs book. Okay, now let's see this problem. So what will be the product? Firstly, NaI4 reacts. NaIO4, it is an oxidizing agent. So here as oxidation will take place first, we will get this product after adding NaIO4. Then on treatment with CCl4, CCl4 is a solvent at 80 degrees Celsius, it undergoes pyrolytic elimination. Okay, how it will take place? There is a hydrogen atom. Now this O minus will abstract this proton and there will formation of double bond and this will eliminate and we get the product as this is the final product of this reaction. Okay, so this is the final product. Let's move on to the another example. So what will be the products formed here? Okay, on treatment with LDA, what is LDA? LDA is a non-nucleophilic base. That means it acts mainly as a base. This is the structure of LDA. Lithium diisopropyl amide. Okay, so here is a proton, right? And it is going to abstract this proton. Why? Because ultimately we want a negative charge in the electronegative atom. So how can we get this negative charge in the electronegative atom? By conjugation, right? So here conjugation will occur and the product will be negative, means lithium plus there will be a double bond formation. This is the product of this step. Then on addition of methyl iodide, this negative charge is again going to get back and this double bond is now going to attack the methyl and iodine will leave. So the final product of this reaction is here will be methyl formation, one, two, three, four, five, six. Yeah. So this will be the final product of this reaction. Now in this problem, what will be the product? So first of all, the lone pair in this nitrogen atom is going to get here and this double bond is now going to attack here. Why? Because this is an electron withdrawing group, right? So if there is a negative charge over here, then it will be stabilized. So this gets here and thus a negative charge is formed here. Okay, in presence of the ether. So the product from here will be double bond nitrogen. Here positive charge will be there and the negative charge over here is again going to abstract a proton from the solution, right? So a hydrogen will be extracted. Okay, and then in the next step there is ethanol in presence of HCl, means acetic hydrolysis will occur. Whenever acetic hydrolysis occurs in this system, then since this is an imine type of system, right? So on hydrolysis it becomes a ketone and the other will remain as usual. Okay, here in the immune system it becomes a ketone on hydrolysis. So this will be the final product of this reaction. Now this is a very good question. Okay, so this one is silyl enol ether. Okay, now this is mercuric iodide. It is a Lewis acid. It is a Lewis acid. Lewis acid undergoes chelation in these cases and also it helps in Michael 1,4 addition. Okay, so first of all this will come here and this is going to attack here through Michael addition due to the presence of this Lewis acid and it will go there and a negative charge will develop there. So the product comes here to be Now the next thing is, what will be the stereochemistry here? Will it be above the plane or below the plane? It seems to be above the plane, right? But this will attack below the plane. Why? This is because there will be a chelation in this ring. Okay, there is a large group tert butyl silyl oxide, and there is an oxygen, right? So there will be above the plane, there will be chelation with the Lewis acid. Okay, there will be chelation here. So because of the chelation, the group is going to attack from below the plane. Though the air is hindered, then also it is going to attack below the plane. So the product will below the attack will be from below. So carbon C, it will become double bond and OMe, and the negative charge which will be here will again attack the silicon. Okay, so it will be SiEt3, and there is a double bond, right? So it will be here. So this will be the product of this reaction. Let's see our next question. So what will be the products formed in this reaction? First of all, LD is given. We know LD is a non-nucleophilic base. Okay, so it will abstract proton. So from where it can abstract proton? Since it is the most acidic proton here available, since on abstracting this proton, a negative charge will be developed, and it will stabilize. Negative charge will stabilize the electron with your star system. Okay, so firstly, a negative charge will be formed here, CO2 Me, here a methyl group, then double bond Me and CO and MET. Then since there is a possibility of formation of a 5-membered ring, 1 2 3 4 5, okay, so it will attack here, and negative charge will be here, and this negative charge will be again stabilized due to conjugation here. So again the next product will be formed, a 5-membered ring, CO2 Me, here Me, again one methyl group is given here, and CON Me2. Now the negative charge in this case will abstract a proton from the solution, and it will become like this. Okay, and in the next step LiBH4 is given. So what is the role of LiBH4? It chemoselectively reduces the ester group. Okay, it will reduce ester to alcohol, so it will give CH2OH, CH2OH, and Me, C double bond O, and Me, sorry, there is 2 Me2. Okay, now in the next step Amberless 15 is given. So you might not know what is Amberless 15. You can consider it it gives H plus ion. Okay, it acts as an acid donor, so H plus donor it acts. Now since nitrogen lone pair is more easily available than compared to oxygen, as it is less electronegative, so it will abstract this proton. After abstracting proton, it can attack here, it will go there, the negative charge, and come back, and this group will move. Okay, it will move as H and Me2. Final, so now we will get our final product. This leads to the formation of 6-membered ring, 1 2 3 4 5 6-membered ring, CH2, oxygen, carbon, double bond, Me. So what will be the product of this reaction? So this will be the final product of this reaction. Okay.